Right, so we're going to try and take the derivative for this equation, but it's an implicit form. It's not solved for x. So we're going to take the derivative. Anytime we take the derivative and we don't have an x with it, we're going to have dy over dx. So my derivative of x squared is going to be 2x. For 3y cubed, it's going to be 9y squared, and then I need to put dy over dx with it. 2xy, I'm going to need to do a product rule with this one. So 2x is my first term. Derivative of y would be dy over dx. Plus my second term, which is y, times the derivative of the first, which is the 2x. So its derivative is 2, and the derivative of 5 is 0. And I can simplify this a little bit. Then if I get the dy over dx terms together and all the other terms on the right-hand side, if I put the 2x and the 2y on the right-hand side, they'll be negative. I can factor out dy over dx. So I'm left with 2x minus a 9y. Then I can divide both sides by that 2x minus 9y. Negative 2x minus 2y over 2x minus 9y. You can leave it like that. The next thing we're going to look at is using that idea of logarithms to take the derivative. If you have a problem where you don't have any logarithms in the problem, we could add logs to the problem by taking the log of both the left side and the right side. And what that allows you to do is now on the right-hand side, I can separate this using my properties for logs. So my properties for logs say if I have division, I can separate this into two separate logarithms. Division I can expand into subtraction. I can also take these exponents and put them in the front as coefficients. And now I no longer have to use chain rule and quotient rule for this one. Oops, I missed my log. It's a natural log, x squared plus 1. And now I can take the derivative implicitly. So the derivative for natural log of y with respect to x is 1 over y times dy over dx. On the right-hand side, the derivative for natural log of x minus 2 is going to be 1 over x minus 2. Derivative for natural log of x squared plus 1 would be 2x over x squared plus 1. I'm going to leave this left side alone for now. Right-hand side, this 2 in the bottom, that 2 in the top can cancel. I'll have x over x squared plus 1. Then I can combine the right side together. I have two separate fractions. I can combine them together and find a common denominator. And the common denominator will just be their product, x minus 2 times x squared plus 1. In the first fraction, that 2 I'm going to have to multiply by x squared plus 1. And in my second fraction, that x in the top, I'll have to multiply by the other denominator, x minus 2. So I still have 1 over y times dy over dx. In the top, if I distribute, I'll have 2x squared plus 2. X squared plus 2 minus x squared plus 2x. That bottom in that factored form. And then combine like terms in the top. I have x squared plus 2x plus 2. X minus 1, x squared plus 1 in the bottom. Now the last thing I need to do is I have this 1 over y on the left-hand side. I want to know what the derivative is, not 1 over y times the derivative. So if I multiply both sides by y, the y's will cancel. I'll have dy over dx. And on the right-hand side, the same thing here. Now, instead of using this y, I can go back to the original problem and I can write what y is equal to in terms of x. X minus 2 squared over x squared plus 1 to the 1/2. And then I can combine some like terms here. So I have an x minus 2 in the top and x minus 2 in the bottom. One of these is going to cancel with one of those. And then in the denominator, I can combine the x squared plus 1 and the x squared plus 1 to the 1/2. And it looks like it's going to be complicated. You're just adding the exponents together. So a 1 plus a 1/2 will give me 3/2 for that one. And you're done. It's still better than doing that quotient rule and chain rule twice.